This instructional video is about solving systems of linear equations. Anytime you have two or more linear equations and they are to be graphed on a same coordinate plane, they're considered a system. In this case, we have two linear equations. One of the ways to solve the equation is by graphing. And to graph, I'm going to use a thing called the intercept. So let's take the first equation, 6x plus 2y is equal to 16. And in my previous instructional videos, we have done this. Let x equal 0. So when you let x equal 0, this whole term x becomes a 0, so I'm going to cover it up to show that it's only 2y is equal to 16, and thus we're going to find the y-intercept. And do that by dividing 2 to both sides. So y, the line goes to the y at the 8. That's the y-intercept. Now to find the x-intercept, we let y equal 0. This time we have a peculiar situation. Since this term is a 0, what we have remaining is just 6x is equal to 16. And when you solve for x, we end up with a fraction. And in this case, they're both divisible by 2, so we have 8 over 3. That's the x and y intercept of the first equation that we're going to graph right now. Here's the coordinate plane. Here's the y-axis. And here is the x-axis. So the line will cross the y at the 8. Boom! There's 8. And it will cross the x-axis at 8 over 3, which is equivalent to saying 2 2/3. So if we're going to approximate this pretty closely, if that's 8, somewhere here must be an 8. There's a 4, there's a 2, and 3 is here. Then 2 2/3 may be somewhere approximately around here. That's 2 2/3, or 8 over 3. Draw a line, and we have a line that's going down from left to right. There it is. Now the second equation. Yeah, we're not done yet. The second one now, it says negative 2x plus y is equal to negative 2. To make this interesting, instead of letting x equals 0 and y equals 0, I'm going to make this into a slope-intercept form. So we're going to add 2x to both sides of the equation. And we end up with y is equal to 2x minus 2. Where we could see that the y-intercept is a negative 2, right here. So if this is 8, negative this way, here's 4, then 2 must be over here, negative 2. And the rise over run, the slope, is 2 over 1. That's the slope, which is 2 over 1. So from here, up 2 over 1, somewhere here. Okay? So now I'm going to draw the line. Let's make it over here instead. And then when I draw it, if I had to estimate, it looks like it should be, looks like a 2. And if that's a 2, then on the y it must be also 2. So I'm going to estimate that the x and y intercept where the two lines intersect, the x and y coordinate I mean, is going to be at 2 and 2. Now how do I know if that's the right answer? Well, you have to substitute the x and y coordinate onto both equations. And if it does equal, in fact, negative 2 on the second equation and 16 on the first, it means it's correct. So let's do that. So if I substitute it in for the first one, 6 times x, which I said it was 2, plus 2 times the y, which is also 2. That gives me 6 times 2, which is 12, plus 2 times 2 is 4. That's 16. There it is. So that one works out. And the second one, negative 2 times x, which we said was 2, plus y, which we said was 2. That better add up to be negative 2. And negative 2 times 2 is negative 4 plus a 2. Does that equal negative 2? Darn tootin'. It sure does. So our estimate was correct. And that's what the systems of linear equation mean. That if you graphed it, your job is to find where they intersect. And in this case, at 2 and positive 2. I mean 2 and 2 on the x and y. Now there are other ways to find where they intersect without graphing. And that's what this instructional video is about. One of my students came over and gave this to me. It's supposed to be some sort of a hermit crab shell, I think. Yeah. Bye-bye. So what's another way? Well, we could use a thing called substitution method. Here's how that works. Remember on this other example, I took the second equation and made it into a slope-intercept form, or sometimes we call this the function form. Well, that's how we do it. We're going to take the second equation and make it into a function form, and we know now already from the previous example that y is equal to 2x minus 2. So let's say this now has become, since we're adding 2x to both sides, it's now y is equal to 2x minus 2. What do you do with that? Well, sometimes I ask the students, what does y equal? They shout, 2x minus 2. What does y equal? 2x minus 2. And I do this sometimes like more than 5 times until they get so burned out. And then I say, all right, then let's take this y, which equals 2x minus 2, and substitute it into the first equation. Because whatever that point is true for the first equation is true for the second equation, so that's where it equals each other. So let's make it equal to each other. So we have 6x plus 2 times y, but what does y equal? 2x minus 2 equals to 16. And we're going to solve for x now. Look, a number outside of parentheses. Distributive property. 6x plus 4x minus 4 equals 16. Usually when you do a distributive property, you end up with a combined alike term. So in this case, we get 6x plus 4x, which is 10x minus the 4. Now all we have to do is go our merry way and look for x by adding 4 to both sides. So 10x is equal to 20. Check this out. Divide the 10 to solve for x. X equals 2. Yeah. Now we found the x. How do you find the y? Well, you could choose to substitute it in for either this x or that x. It doesn't matter. I always tell the kids, look for the easy one to plug in. It looks like the second one is the easier looking one. So I'm going to go negative 2 times x, which is 2 that we just found, plus the y. Now we just solve for y instead. So this becomes negative 4 plus y. Negative y tells negative 4, you, get out. So you add the additive inverse. So y is equal to 2. And there's your x and y. And I'm not going to bother checking this time because we already did it over here. So that's the second way, by linear substitution. We saw by graphing. We saw by linear substitution. One more. We take the same thing this time, and we're going to combine them. And we call this linear combination. We're going to combine the two. Or sometimes we call it linear elimination method because we're trying to eliminate one of the variables. Check this out. I'm going to multiply to the second equation by 3. Why? You'll see why in a minute. A number outside of parentheses. I'm going to do a distributive property. What do I get? I end up with negative 6x plus 3y equals negative 6. Since I haven't done anything to the first equation, I'm just going to write it down on top of the second one. And you could already recognize what's going to happen if I combine the first and second equations together, meaning add or subtract. That's right. 6x minus 6x, they become 0. They cancel out. All that remains is positive 2y, positive 3y, positive 5y. 16 minus 6, 10. Divide 5 to both sides. Y equals, bam, 2. And you can see how you're going to find the x, just like before when we did substitution. You take that newfound variable, plug it back into the original, do the same thing with this guy. Take the y, plug into one of the equations. It doesn't matter which, I'll just do it on the first one. And you should get the same answer as we've been finding for the third time now. 6x plus 4 is equal to 16, minus 4 to both sides. 6x is equal to 12. Divide the 6 to both sides. X equals, which do you like the best? Solve by graphing, solve by linear substitution, or solve by linear combination, or the elimination method. It all depends on what the circumstances is. Okay? Enjoy!